Okay, now we're going to do a unit on electric charge. And this is kind of the foundation of studying electricity. And so we need to understand at this level before we go on to other measurements within the electrical field. So let's go over some objectives that we want to achieve during this lesson. We want to understand electric charge and how it is measured. We want to grasp the direction of electrical charge flow, the direction in which it moves. And we want to know how to calculate electric charge given a specific amount of electrons. Okay, so we're going to do a review at the end. We'll test to make sure that we understand these principles after the lesson and do a little follow-up there. So let's get started. To understand electrical charge, we need to understand the foundation that this man created. His name is Charles de Coulomb. It's been simplified to just Coulomb as his last name. And he developed what is known as Coulomb's law, which will be a future lesson that we are going to study. But this graphic here at the bottom of the page shows the general principle of what he found. And he found that a given charge of a negative quantity is attracted to a given charge of a positive quantity. And if you have a negative charge of a given quantity in the presence of a negative charge of another quantity, they are actually going to repel one another. So we've heard the term opposites attract, and that is part of what he developed with Coulomb's law. Of course, he had formulas to show the strength of attraction based on the amount of charge and things like that we will not be getting into in this lesson. But just to understand that principle that opposites attract and like charges will repel from one another is what we're going to need to know today. The SI unit of electrical charge is actually named after him. It's called the Coulomb. So what we're going to be studying today is electric charge, and in essence we're going to be studying coulombs. The term SI might be new to you. SI, or System International Units, or sometimes it's International System Units, depending on which country you're in, is probably something that you may not have heard before, but if you've heard of the metric system, that is the System International Unit. So the Coulomb is a metric measurement. Okay, the Coulomb as that metric unit. Let's look at it. So we have to go back to the atom. And just a quick review of what an atom is. We have protons, neutrons, and electrons. That makes up our atom. The proton, which is positive in charge, and the neutron, which is neutral in charge, are in the nucleus, what make up the nucleus here. And the proton, positively charged, and the neutron, which is neutral in charge, are grouped together here in the center called the nucleus. And they stay fairly stable in that position. It does rotate a little bit around its own axis, but they don't fly around. They're not orbitals. A electron, which is negative in charge, is what is termed an orbital. It will fly around the nucleus, and it has a negative in charge, like I said, and the proton has a positive charge. And it's that mutual attraction, remember opposites attract, that keep the electrons from flying away from this atom. And for that very reason, in a stable atom, we have the same number of protons as electrons. So in a stable atom, it's very important, in a stable atom, the proton count and the electron count will equal one another. Okay? So these electrons, which are negative in charge, can be built up into a collection of electrons, and this sac here is going to represent a collection of electrons. And once we get to a specific quantity in that sac, in that collection, it's going to be termed a Coulomb. So a Coulomb is just a collection of electrons. And those electrons altogether will have a specific charge. And we said electrons are negative in charge, so this sac here will have a collective negative charge. We'll get into where that plays in an electrical circuit in just a moment. The Coulomb is represented by the letter Q in math equations. Q actually is the representation for electrical charge. So a given charge in a math equation will be represented by the letter Q. So in this case, if this sac had enough electrons in it to equal 1 Coulomb, we're going to find out the quantity of electrons that make up a Coulomb in just a moment. But let's just say this sac has enough electrons in it to compile 1 Coulomb. You could term that Q equals 1, in this case C. So a Coulomb unit is abbreviated by the letter C. You've probably heard of volts. We're going to study volts in another lesson, but often the term volts is simplified with the letter V. The unit Coulomb is simplified by the letter C. Okay, so just very important to remember, Q represents charge in math equations, and C is the unit of charge. Okay, so very important distinction. Q represents the amounts, C is the units. Okay, so let's look at this. A Coulomb is represented by the letter Q in math equations. Let's see how many electrons it takes for us to actually make up a Coulomb. Okay, so 1 Coulomb, which we learned that we can represent by the letter Q here, is 6242 with 15 zeros behind it, electrons. Now the way to actually say that is 6 exa 242 peta electrons. Now that's difficult. It's not worth memorizing or understanding. Let's just use some scientific notation here to figure out what we want. So Q is going to equal 6.242 times 10 to the 18th electrons. We had a lesson on scientific notation, and if you need to review that, you can watch my video on that. But that is 1 Coulomb, 6.242 times 10 to the 18th electrons. Now remember, electrons are extremely small. So I'm representing it here with a sac, but an electron will, that quantity of electrons would still be an extremely small amount of space. Let's look at this in action. So here is a representation of what a flashlight essentially is. A flashlight has a couple batteries in it. They're put in series. We're going to learn that term series in a future lesson, but they're put back to back. And then a light bulb is connected in that circuit, and there is a switch that you can turn on and off the flashlight. Okay, so currently the switch is open here, and we have nothing happening. We have a potential of something to happen because the battery holds a potential, as long as we have a good battery here. And we have a potential to do some work here with the light bulb, but currently it is not lit. Now let's close that switch, and I have simplified it by just removing the switch altogether, so graphically it'll look clean. And so I have just closed the switch, and something's going to happen here. I'm showing the light bulb being lit, and we are actually going to have some electrical charge, a quantity of electrical charge here, start to move in this circuit. Okay, so I'm still using my same graphic here of this sac here is going to be 1 Coulomb of charge, which is going to be equal to 6.242 times 10 to the 18th electrons. Okay, those electrons are going to be altogether negative in charge. Because electrons are negative in charge, we've got a grouping of electrons. They are negative. So they are actually going to be attracted to the positive terminal of the battery. You see this direction already starting to happen here. So they are going to continue to move in that particular direction, which I'm indicating with the arrows here. So this charge, this quantity of charge, is moving from the negative side of the battery. The flat side of a battery is the negative side, and the side that has this little dimple on it is the positive side. It's denoted here with a plus sign as well. I think I also show that here with a negative symbol and a positive symbol in the circuit. So this is our negative side of our circuit, and this is our positive side. And my coulombs, my collection of electrons, are attracted from the negative terminal of the battery to the positive terminal of the battery. So looking again at our atom, we have these electrons here, and the electrons are actually what are moving in the circuit. The protons and the neutrons are staying pat, and we're actually sharing electrons from one atom to another. We're going to have a lesson that's going to graphically show that in more detail in the future. But in this case, just remember that this quantity of electrical charge is moving from the negative side of the battery to the positive side. Electrons, remember, as we've said, have a negative charge. So all of these here are negative quantities, and they will be moving from the negative side of the battery to the positive side of the battery. So I have a little animation here that's just showing this flow, and this is a completed circuit, and this is what is happening in a flashlight when you turn it on. We're having these coulombs of electrical charge, a collection of electrons, moving from the negative side of the battery to the positive side of the battery. And in doing so, they're going across a load, in this case the light bulb, and creating light. So groupings of electrons, or coulombs, move from the negative side of the source to the positive side of the source. Okay, very important to remember that. Groupings of electrons, or coulombs, move from the negative side of the source to the positive side of the source. And in this case, the source is a battery, but it could be other types of sources, like what you get out of your wall outlet as far as AC goes. This is DC, or direct current. And the study of electricity is essentially the study of electrons moving in a completed circuit. Okay, so that's what we're doing here. This is the foundation of us studying electricity and how things happen. So we've already understood one very important principle, is what is actually moving in a circuit is the electrons. And since they are negative in fashion, they are going to move from the negative side of the source to the positive side of the source. Let's do some calculations. We said that 1 Coulomb is equal to 6 exa 242 peta electrons. Okay, so easier way to say that is 6.242 times 10 to the 18th electrons. Okay, so let's come up with an equation here. If you're given a set of electrons that is 1.2484 times 10 to the 18th, calculate the number of coulombs that you actually have. Okay, so let's write this out in equation form. Remember, Q represents a quantity of charge, okay, and that's measured in coulombs. So Q is going to equal the given set of electrons that we have, okay, so 1.2484 times 10 to the 18th. And we know that 1 Coulomb is equal to 6.242 times 10 to the 18 electrons. So if we take that amount of electrons and we divide it into the total amount of electrons that we have, we will come up with the amount of coulombs that we have. Now, if you remember from division in math class, if you have the same number in the numerator and the denominator, you can cancel those out. So this times 10 to the 18 and times 10 to the 18, those will cancel each other out. So actually all we need to do when we punch this into a calculator is we need to take the 1.2484 and divide it by 6.242, okay? And if we do that, we are going to wind up with 0.2 coulombs, okay? That makes sense because this number, it's 1.2 and this is 6.2, and they're both multiplied by the same number of zeros, is smaller. The 1.2 is smaller than the 6.2, so we're going to get a number smaller than 1 coulomb, and in this case, it is 0.2 coulombs. So that's how you would calculate, given a set of electrons, how you would calculate how many coulombs that represents. Okay, let's do this in the opposite direction, okay? So we have 1 coulomb equals that 6 exa 242 peta electrons, which we simplify as 6.242 times 10 to the 18th electrons. And in this case, we're given the amount in coulombs. So I have 2.2 coulombs in my given set, and I want to calculate how many electrons that actually represents. Okay. So in this case, we're going to take our 2.2 coulombs, and we know that we have 6.242 times 10 to the 18th electrons in 1 coulomb. That will give me my number of electrons. So going back just here, just for a moment, we don't necessarily need to actually multiply this out. All we have to do is multiply my 2.2 times my 6.242, and then we know that that quotient will need to be, that product will need to be multiplied again by this times 10 to the 18th. Okay, so here, if we take 2.2 coulombs and we multiply it times 6.242 electrons, we're going to get 13.7324. And then we know that we have to multiply that by the number of zeros that are going to be behind it. And so we'll have the times 10 to the 18th electrons. Okay? So that's how you would do the calculation in a forward fashion and in a backwards fashion, going from electrons to coulombs and coulombs back to electrons. Fairly straightforward. Okay? Let's review. What is electrical charge and how is it measured? Okay, think about that for a minute. Okay. Electrical charge is a collection of electrons, and that collection of electrons is termed a coulomb. A coulomb equals 6.242 times 10 to the 18 electrons. Okay. And Q denotes charge, and it is measured in coulombs, which we abbreviate C. Okay, so what is electrical charge? It is a collection of electrons, and it's that specific quantity of electrons, 6.242 times 10 to the 18th, and you can represent it, you can denote it by the letter Q, and it's measured in coulombs C. Grouping of electrons or coulombs move in which direction within an electrical circuit? Okay, so since electrons carry a negative charge, and since opposites attract, that grouping of electrons, or a coulomb or coulombs, will move from the negative side of the source to the positive side. I said they will move toward the positive side of the source. So they're coming out of the negative side of the source and they're moving towards the positive side of the source. Very, very fundamental, important to understand that flow. And that is, the flow happens in that direction because electrons are what are actually moving in an electrical circuit, and electrons are negative in charge, so obviously they are going to be attracted to the positive terminal of the battery. Okay, let's calculate how many electrons are in 2 coulombs. Okay, so Q, remember, is the denotes electrical charge, and we have 2 coulombs, And if we multiply that times 6.242 times 10 to the 18th electrons, that is how many electrons are in 1 Coulomb. We have 2. We will wind up with 12.484 times 10 to the 18th electrons. Okay, so that is the review of this lesson. I hope that is interesting to you. We are actually going to build on this foundation from this lesson, and we're going to learn what an ampere is, which a lot of people just abbreviate amp, based on our understanding of what electrical charge is. So look for that lesson in the future, and we'll see you then.